Q is going to represent heat. Okay, so if we have two systems. And this is the metal. And we have this metal, it's going to be really, really hot, right? Really, really hot metal. And we're going to drop it into what? What's going to happen to the metal? So why is that room temperature?
The temperature's gonna go down.
Temperature's going to go down. Wait, wait. Hold on. It's not chapter 2. It's still kind of chapter 2-ish.
Oh, God.
2-ish. Okay, so you said the temperature of the water is going to go down?
No, the metal temperature is gonna drop down to the water, right?
Okay, yes. So the metal temperature is going to drop down. So what's going to happen to the water?
It's gonna heat up a little bit.
It's going to It's going to heat up, right? It's not necessarily warm, depending on how hot it's right? So that process is called heat transfer, right? So if we look at it, Q of the water, Q meaning heat again, is going to equal Q of metal. Minus, right? So in other words, the heat that's going to be lost from the metal is going to be going to the water. Okay. Does that make sense?
Yeah.
Okay. So in other words, heat is going to be transferred. What is that law? What are the laws? What laws do you guys know?
Mass and energy. Right?
What about mass and energy?
The
Mass and energy, right? Conservation of mass and energy. What does that mean? What does it mean?
how much heat takes to 1% of water?
Now you're just throwing things out there. Come on, think about what it means. What did you say? What's conservation mean?
What you put in, you get out.
What we get in, what you put in, you get out, right? In other words, it's never going to be lost. What's going to happen to it?
It's constant?
It's going to transfer, right? So that means that it's going to transfer, right? And that basically proves it right there, right? Because we know that if you stick a hot stone in water, that water is going to get warm, right? And that stone eventually is going to get cold, and then eventually you're going to get balanced out, right? So in other words, all that energy is being transferred to the water, right? That's okay, so here, delta T means temperature, right? Change in temperature. Delta. So delta T would be change in temperature. The way that we calculate delta T T final minus T initial. Oh my gosh, you're so sorry. Did you guys do anything that was T final minus T initial? Anything for a lab recently?
Yeah.
You know, it must be Monday or something.
It
It's
is.
real quiet.
I
I'm
feel like my
struggling.
brain's not working right now. And then your computer's echoing and it's really irritating.
Oh,
Can you hear it? Like every time we talk, it's like an echo.
is that better?
Like when we did the Excel sheets, didn't we minus like to make it carry?
Like you took the difference.
Yeah,
right?
we took the difference.
Of your final minus your initial, right?
Mhm.
Mhm.
Is
So
that
you
right?
took the delta T, right? You
Yeah.
got the change in temperature, right? Okay, so you guys already know how to do delta T, right? Pretty simple. Now C. This C is not the speed of light. I know we talked about the speed of light, but I know you gotta be careful. See, the thing about chemists, as I told you, we get lazy, and then one chemist will start doing something, another chemist will start doing something, and so this happens all the time, all the time. Drives me crazy. So this C means something different. It means specific. So specific heat is just basically a constant that's going to be given to you. right? So water has a specific heat, ice has a specific heat, steam has a specific heat. Okay. So specific heat of water, that C is going to be 100 calories. Per 1 gram. 1 Celsius or temperature. This is a water. It's the same. Okay, so if we wanted to calculate the heat that's going to be associated with that water, that we just dropped that piece of metal in it, right? We would take the mass of the water, M means mass, times the specific heat of the water, times the change in temperature. So let's make an assumption, right? Let's make some assumptions. So let's say we have 10 grams. You guys see that on my board? Or is it-
The 100, the
It's a little
1,000
messy.
calories kind of went away.
It's one.
It's like-
So 1 calorie over 1 gram and 1 degree Celsius. 4.
So you guys can see that.
And what is that? Yeah.
So we have 10.0 grams of water. Okay, we know the specific heat of water. Can be equal to that. And let's say the temperature went from 12 degrees Celsius. That's going to be our initial temperature. To 100 degrees Celsius. That's going to be our T5.
What is the mass though? Of my mass?
I don't know, you told me what's the mass? You see anything up there that would be mass? What is the units for mass? What was it?
2.0 grams.
10.0 grams. So we have the mass of the water. We have the change in temperature. Can you guys calculate? Solve for Q. How do I calculate the change in temperature?
Minus initial.
So our final is what? Minus our initial 12. That equals. Okay. You know where our C is. What is our C again? CH2O is
1.0 calories.
gram. Okay. How many grams do we have?
10.
10. Okay, so let's go ahead and plug it into this equation. So we have 10.0 grams times 1.001 calories grams Celsius times that change. Okay, so Celsius is going to cancel out, grams is going to cancel out. So this is going to be 880. Let me say fig should I have? Three here. There's 3 here, and there's how many here? 2. So then how many should I have?
2.
So I have 2.
Yes.
Okay, there we go. Okay. Pretty simple, right? So then we know that the amount of heat that's lost by this metal is going to be what? What's going to be the Q per metal? So if the heat for the water was 880 calories, so what is going to be Q per metal?
880 or 800.
Minus 880 calories, right? Because it's losing it. You guys understand? Questions?
Can we do another problem?
Sure.
Because I'm not, one more and I'll understand.
One more, you understand? Promise.
Yeah, I understand the process and how it works, but I just need to do it one more time.
Okay. Everybody got this down?
Yeah, let's write it later here.
He's everywhere.
So back to stuff. That's specific to water. Mass metal is going to weigh. Temperature. 25. So. And we'll give you the C value for it. Okay, so how would I do this? Okay, so
Subtract final from.
we're gonna solve for our delta t. That's what we're telling me?
Yeah.
Okay, so our delta t is gonna be
Negative
Final.
198.
our mass.
75.2.
Our C.
Um,
It's gonna be the heavy lifting.
The math,
This is like negative.
negative 196.17,
Okay, you said negative,
196.117,
okay, negative
But-
186,
96,
117.
96.
Oh, 96.
Yeah, I think if I did it right, I don't know if anybody else wants to do this.
196.117.
Yes. I just typed.
0.117.
Yes.
Should be more than that.
I got negative 28.
Yeah, that's what,
Yeah?
that what you got.
Okay, so you got
Yeah.
Negative 28,
Oh, that's what she got. What are we multiplying?
2837.
Oh, dang it. 28,037. Point.
037. Point.
Oh, I forgot to do this.
I got it. Because you have to times
Oh,
it
it's
by
75
the-
times 1.883, right?
Oh, so yeah.
Oh, I got that.
You got
Yeah,
that?
yeah.
I got that.
Yeah, I thought it was so old because it looked so long.
That's the value he gets.
Yeah, it's a huge.
So you have to times this and then times this.
Oh,
And then
like
goes back.
everything.
And then times everything.
Was that?
No,
So you have to times 7.
Okay,
7.5
so
times
negative
0.2 times 1.883 times 1 negative 90. Negative
Okay.
2.0.
That's what we got, right?
Yeah.
Okay. Okay, how many stick figs? 2?
3.
Are you sure?
Well, the 27.
it's gonna be 3.
Where did you get 27?
Oh.
This is addition, right? But then this brings it to 3, right?
So three.
I'm sorry, this is subtraction, right? So that moves us to 3 sig figs, right? So we got 3 sig figs, right? We'll plug it in, because if we do this, right? This is 225 minus 27, right? Where does the significance in? After here, right? So then all three digits are going to be significant. Next, let's get negative. Okay, so then you're gonna have 3 significant figures, right? Round it up. We use this number to round. Are we rounding up or down or leave it alone? Nothing there, right? So 3 sig figs. Now we have to multiply. There's 3 here. How many here? 4. And how many here? 3. So then how many sig figs should I have since I'm multiplying? 3 sig figs. Okay, so then my answer should be
-280.
So then you put a decimal since it's a zero.
Let's control all this.
okay, so that's 1, 2, 3, 4. So 4 calories. So that gives me 3 sig figs. I use scientific notation to make it easier for me. So I can easily write 3 sig figs. Right? Because I look at this 3, right? Decide whether I round it up. Right? So then I don't round up that 0. So but I need to show that that 0 is significant. This is the easiest way of doing it. Scientific notation. Okay, questions? Thank you. Forgot my name. Thank you. Okay, so then what about the water? How do I calculate the heat of the water? I'm gonna throw something at you. That doesn't calculate the heat of the water, it calculates the temperature of the water. That's not the same thing.
Okay, that like it.
Okay, so how would you calculate the heat of the water?
Just divide it, right?
You're just gonna divide it.
Well, the heat of the water, you're gonna.
What does the law of conservation say? What does the law of conservation say? Tell me. What was that?
What you put in, you get out.
What you put in, you must get out, right? So if I'm putting in negative 2.80 times 10 to the 4th calories of heat, how much must be going into the water? Same amount, right? But it's going to be a positive value, right? Because it's going into the water, right? Because then remember this, Q metal equals minus Q water. So then that means, yeah, negative 0.80 times 10 to the 4th calories. Okay, does that make sense? They always have to account for each other, right? Never going to be lost anywhere. You're just transferring. Okay, so like for instance, you got money. You got cash money? How much money you got? Well, on you right now. You got $200 on you right now? Okay, so take out a bill. You get that.
Cash up. I need to go change the equation.
Okay, so, okay, now I want you guys to do this. Now think about this really well. Okay, you guys think about it, everybody's thinking, right? You got your mind thought. Okay, so he had $100 and he gave me $100, right? How much money did he lose? $100. How much money did I gain? $100. Thank you. Okay, so does that work? You guys understand? You see how that works, right? So money is just being transferred, right? His money, he lost it. I gained it, right? Okay, makes sense? So that's the same thing that's happening with heat. Get your money back.
If not, I'll take
$100. Hey, nobody robbed him. Okay, so are there any questions?
No, sir.
No questions. Pretty simple, right? Not too hard. So the hardest part is remembering the equation, right? And in most cases, that equation is going to be provided for you, okay? You just got to remember how to use it. Okay? Now, let's see if we can add a little angst to it, right? Because this is too easy, right? You guys want something more challenging. Come here. Work hard, right? Wait, you're shaking your head, just a little bit nodding, right? Okay, let's see if we can make it a little more challenging. Everybody got this? Take a picture. And we pose. Keep walking around with fire. Fires. But so I took his money, right? everybody got it, right? So you guys are going to be making what is called a temperature curve. You guys kind of see this.
Another graph for Excel?
Yeah, send me another graph of Excel. It's good for graph. So figure one, everybody sees figure one. Right, so let me kind of explain to you what happens. Because there's a little bit more that you guys need to know. You guys got a pretty good understanding of what happens with the transfer of heat. Okay. Okay, so this is called the temperature curve. So this is what happens over time. So we started off with something that was frozen, right? Initially, it starts off as a block of ice, right? So it's negative 20 degrees. It's really cold outside. It's a big old block of ice, right? As we raise the temperature over time, what happens is it gets to this point. This is kind of like a little plateau. Now, this little plateau is like a hump that you got to get over, right? And this hump is called the enthalpy. Delta H. Fusion, right? So it's a hump that you got to get over, right? So that you can actually melt. Okay. So there's a value that is given to this. And it's going to be also based upon not mass, but what we call quantity, moles, typically, right? So depending on how many moles you have, it's going to take a little bit more energy to get over that hump. But that value is going to be pretty consistent, but it's going to be based upon that quantity, right? So you have to change your mass to moles, right? You guys are going to say, oh, moles, right? That's what you should be asking. It's not that little animal that it pops out, you know, that's blind and everything. You guys know about the mole, right? That little fuzzy animal, cute animal it looks like, right? That dig holes in our ground. Okay, so it's not that type of mole, right? A mole is kind of like a dozen. Do you guys know what a dozen is? 12 of what? Dozen donuts? Yeah. 12 of what though? Well, obviously he said donuts. Is it only donuts? Can I have a dozen? I can have a dozen of eggs. I can have a dozen of friends. I can have a dozen of chickens, right? Dozen of girlfriends, right? Dozen of just about anything, right? So that's a dozen, right? And we know that it always associated with 12, right? Okay, so we know that anytime that anybody says a dozen, it means 12. When people say mole in chemistry, that means 3 point. Sorry, I'm just gonna on board. Sorry, it's not. It's 6.022 times 10 to the 23rd. Okay. You guys get that down? 6.022 times 10 to the 23rd. That's going to equal 1 mole. Kind of like a dozen. Equals 12, right? So I can have a mole of kids. I can have a mole of girlfriends. I can have a mole of boyfriends. I can have a mole of anything, right? Mole of donuts, mole of pennies, right? mole of atoms, mole of molecules, right? Anything. Okay, so you guys know what a mole is, right? Now this is one thing that you want to always know, right? In chemistry, what a mole is. So you're gonna tattoo it on your butts. 1 mole equals, right? If I just check everybody looking like this, you know, I know what you're doing, huh? All right, so 1 mole is always going to equal that. That's going to be quantity, right? You guys are familiar with quantity, right? You guys are a group of how many? Oh, right here, sorry. You guys are a group of 3, right? So group of 3, that's quantity, 3, right? Okay, so mole is going to be quantity, okay? So when we talk about the heat of fusion, it's going to be based sort of on quantity, how much you have, right? That's how much energy it's going to take to kind of get over that hump. So if I have a small block of ice, it's not going to take as much energy to get over that hump, right? But if I have a big block of ice, it's going to take more energy. Doesn't that make sense?
Yeah.
Okay, so this plateau is that hump, and that happens at 0 degrees Celsius for water, right? So we know that water freezes at 0 degrees Celsius. It also starts to melt at 0 degrees Celsius. But we need enough energy to get over that hump. Okay, so when we talk about that heat, that Q, the Q going from 0, I mean from -20 to 0, that's going to equal Q C M C delta T, and this is C ice. Okay, because the value, the specific heat for ice is going to be different from the specific heat for water. Okay, then it's going to be the heat of fusion, right? To get us to melt. Okay, then it's going to be Q equal MC water. So now we're going from 0 to 100. And again, this is where water's going to be, right? Because after 0 degrees, when it gets to 1 degrees, it becomes water. Right? And then it's going to plateau again. This here is going to be delta H vaporization. Okay, delta H vapor. And then if we want to go to 120, it's going to be Q equals M T. Okay. Questions? Okay, now when we talk about the heat of this entire thing, right? The Q so if we're going from a block of ice all the way to steam, we have to take into consideration all of these steps. Okay. So Q is going to equal, I'm going to call this Q ice. And then this is going to be delta H. Moles. And use the letter N. Moles. Water. Okay, so it's gonna be the sum of all of them together. Okay. So if we're going from a block of ice to steam, we have to take in consideration each of those transitions, right? Because those are called transitions, right? Just remember that. We're going from solid, that ice, to steam. Okay. So you're going through all of those different transitions, those transition states. And to go through those transitions, you gotta get over that hump. That means that you gotta put in a little more energy to get over that hump. Does that make sense? How many of you guys drive in from Columbia? I mean, drive in this way.
Oh.
190. Okay, so now, if you guys are going up that hill and you put your car in neutral, right, that Columbia hill, what happens? It's gonna go back. So that means you gotta give it a little more. You gotta give it a little more gas to get over that hill, right? When you take a little more gas, you're wondering like, why am I going through gas so much? Because you're trying to get over that hill, right? It takes a little bit more to get over that hill. Okay, that's what happens in chemistry as well when we go through those transitional states. Okay, so when we're going from that solid for liquid, we got to give it a little bit more to get over that hump. Okay. Does that make sense? Okay, so today what you guys are going to be doing, you're actually going to be starting with water. You're just going to boil. You're going to be at this point. So you're going to start somewhere in here, from here, and you're going to go somewhere in here. Okay, and this is the part of the curve that you guys are going to be generating. So you're going to be taking the temperature as it goes from water up to the point where it goes to steam. Okay, and so you're going to keep track of the temperature. So you're going to be using this nice little probe. I'm going to bring out some computers for you guys to hook your lab probe up to it. You guys take a look. You're going to have to start this last week, right? Start getting it together. So you need your cord. I haven't got the cord this book yet. Working. This allows it to be hooked up to the computer. And you'll need a probe. If you want to get fancy, there should be 2 probes in there. You can keep one at room temperature, and then you can keep one in your water so you can see how much it changes. Then I'll show you guys how to actually play with the program here in a second. Now, the first thing that you want to do is when you plug it in, you want to make sure that the probes are working.
My kids will be like, oh, mom's computer. Oh, my daughter's 6 and my son's, he just turned 3 yesterday. 21. I think I went to school with
Sure you got last night?
no more.
At the work, yeah.
You look familiar. I was like, you graduated 2018?
I just graduated last year.
Was it P? It's probably PE. No, it wasn't PE because I had doctor. I had
Let me see if I can pull it up to my screen.
There was only 2 girls in that class.
No, there's a short.
We have to go get a computer, right? Or,
We'll get one for you.
okay.
Was it Mr. Martin? How did you do Mr. Martin?
No.
Was it? No, because Miss More History.
Yeah.
I just remember. I probably wasn't elected.
Won't be filling in.
I had,
Oh, no, you already graduated. I was a senior. The only class I had that was lower was my world history class. What? You don't have elective ones? I couldn't take electives because my grades, I know my classes, and I'm gonna transfer over to because I was in college class. So I missed a lot of like my high school. So I had three.
I should have marked this for.
I had Mr. Dawson, Sly, and I had Mr. Martin, big old booty. I had Miss Quantity. I hated her.
I think I love this one. She's my senior.
I like her.
Yeah, it's Garcia. Senora.
Senora Garcia, that's where you were.
Yeah,
Yeah, you were in Spanish class.
I was in Spanish.
Okay, we got 5 groups, right?
I was like, I remember taking high school. No, because I have world history with Dr.
Oh, so it can't be.
Which way do you guys?
Yeah, it can be.
Where'd you go? Wait,
Yeah. We are thinking. First time we. That's all we know. Yeah. Hold up.
no, where'd you go to the?
Okay, so try to log in, and if you're having trouble logging in, it may.
I know last time when I first did show up, you guys showed up for the store and I had to.
I think it's fine.
You guys doing okay?
Oh.
Go ahead. Yeah. Yeah, 4 labs.
He said that the materials.
So you got 4 labs. Okay, but we have 5.
So yeah, I
Oh
spent
my
30 back
God.
here. Yeah, actually, I think I'll be. You know, I go early. Because
I was waiting for it to be graded.
Oh, me too. I leave Kalinga at 12:15.
So those tomorrow, what I would like you guys to do, you guys are gonna come, and then I'm gonna have you guys meet me in the basic building, because we're pregnant. And we're gonna get you guys started on a non-radioactive. Yeah.
I don't know how to use the boxes. Oh, no, I've heard. Oh, I'll show you.
Yes, I may. You know what the person said? Oh, see, good friends, they just take your stuff. Okay. we'll
I'm
see.
sure I didn't just in case.
What does it look like? Okay, so then you probably packed it up.
Oh,
So when you just.
Oh, we didn't put the
procedure
procedure
yet.
I have the lab report.
I didn't do it, so they talked about the procedure of how it was done, like step by step. I was stopped 5 points.
Make it paper. She was like, "Make my own."
Angelia. It's Angelia. Angelia. Overall, it was good, right? No, even though I missed the procedure portion. Overall, it was okay. 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 Okay.
Next time, just make sure you put your procedure in the material.
Okay, yeah, can I put the material? Yeah, I put the materials. I didn't know we had to put the procedure. So, okay, but overall, it was okay though.
Well, I'm 30. Over 24 hours later, I just got
Yeah, the ground is so, the ground is so glad that we so long.
Yeah, I told you. I knew it was easy. I just didn't know how to put it all.
No, I think it's really good to the class. But I kept watching the video and it was
the video since he was doing
that was about way back in
since he was
background and it like kept playing.
Oh no, I kept that too. I did too.
Yeah, I just want fast forward to the course that I needed. So if it was the tips, I went to the tips. If it was like.
There was a 1.5.
I just put 1,000. Oh, I just rounded it down to 1,000 because it would just make more sense.
Okay, so yeah.
I just put 1,000.
I did 1,000.
I just put 1,000 because I was like, it doesn't make sense. I was just like, whatever. I was like, I'm just gonna write it down. It's just gonna, literally, it's just gonna make a point. It's still kind of nice. I was not bad. I'm just kidding.
I'm just gonna wait for something. I don't want to do things at once. This thing, right?
Oh, they're cute. Is that you driving? Ray Charles. Oh, shit. Tell me, I want to know, did you believe product?
This.
That's nice. Where's mine?
Okay, so how's it going?
Great.
We have one.
Yeah, I lived to that one. I had to my boyfriend.
Oh, you just don't want to.
So everyone able to log in except. we're able to log in. What's that?
It's working though, right? Grab it. I haven't seen it.
Wait, so your dog doesn't do.
No, they're separate. My cat's at my house and his dogs are actually.
Ain't nobody texting us?
Yeah.
Oh,
They
they
live
phone
together.
blowing
My cat- my
Oh,
cat-
for real? It's blowing up?
Yeah.
Fourth of July?
One because my boyfriend's away.
There ain't nobody
And two,
worried.
he's talking about, like, yeah, that's this one is the bottom. This one's number 2. This one, now that one's working. Well, like we were changing the temperature at all. I don't know.
Oh, no.
Yeah, put it between your legs. A rectal mother.
That's why I said, that's why I said. That's why I said, show your butt in this. I did to my son.
I know.
I won't let him.
Animals, I just go.
When they cry, whatever.
I took my son to the hospital, they stuck out my spot, like he's freaking free. Yeah. It's the most accurate.
Yeah, or if you're like, but.
It's the most accurate. I'm surprised they don't do it to actual adults.
No, it's just a little tiny.
It's just like literally like just this much filling. Just like this much. It's like this whole big old thing, just for a little bit.
Let loose.
My son's like, ah. I felt so bad for her.
Yeah, we're going. I want to take a walk. Oh, no, we're just
This.
tomorrow.
This one's due now. When is it?
Oh, I don't know. I can send it in.
Oh,
That's
I
what I
haven't
was like,
turned it in.
I don't know. What is it?
It's Wednesday. We have to try and you have to take pictures and upload it.
So you don't have to do it.
Okay.
You don't have to write it up like a report.
No,
It would make no sense.
I was trying to submit it, but I. That's the one from last week that we did on the way and stuff. Just take photos. You have to do your own part on it, right?
You have to do your own part on this
I
thing.
know
They
we
can
have.
take pictures.
Just have to find out where- Okay, you guys ready to put this to work?
This charger doesn't work.
Try this. That's already doesn't work.
I think the bottom.
Oh, honestly. Oh, wait.
We're temp one, dude. We're temp one.
What?
We're temp
Yeah.
one.
No, I am.
No, because temp one
See, now you're
is moving.
Try sitting on it. He said on bones.
It's going up faster.
So you guys ready to go to the lab, bro?
Yeah, no, we get meant to cool down now.
Log it first, log it first.
Yours going up, mine's going down.
That's why I think
I wanna
that's-
say this. So you keep that whole.
Drugs.
What drugs?
It smells like medicine.
Like Vicks or what?
No. it's not.
Penicillin?
It's like a chemical. Okay, so let me.
That was the last one.
Yeah.
I did.
He's reminiscent.
Ivan, are you there?
We're doing a roll call?
No, it's just, because he said it was muted for him. I just saw a message.
We do have to do this?
Oh, yes. And then that. I was looking into the.
Okay, if you guys know the Logger Pro, this is what you guys should see. You guys see that?
Like different. Oh, I mean, like, I just typed it in like,
And how's it going with
I
your
just
notes?
think the chemistry, chemistry theory.
Nope.
I think I was mad. And I sure was listening to music on the play. I don't know, I think of the artist. So my idea was like, you have to use like, I don't even have to be the most popular song. don't even know them.
The one that we have to do it alone.
Yeah, that's right. Yeah, yeah. It's just. See, look.
That one was so cool.
Yeah. Right? I wish we had it.
That's so embarrassing.
It's gonna be like project by ourselves. I would like that.
I don't even know how to do that. Or we can still do that. We can have our main finger and we can have our back.
So you know how you use your weight? I'll do the vocals just to show out for you. So you know how you make like one big pop in your songs, like that emphasis if you do all the songs. You know what I'm saying? If you do one fucking song.
Don't you be like, I got the blues.
I'm like,
And was that Abdul song? That was really good.
yeah. I was listening to you.
I wouldn't even make it. This one's fire. This is fire. We'll go back to Simpsons, The Simpsons, bro, with saxophone. The one where the little girl got the saxophone.
But you can
Bro, The Simpsons.
You know what I'm saying? Art movie. Then that changes the whole genre. You know what I'm saying? Because there's some good like some of the like old classics that we all like.
Okay, guys, that's it? Are the pros working?
I'm just doing the
What are we testing?
Right. For this one, it would have been like 1, 2, 5, or this one. Yeah, all of those because they're only very 5. Because the decimal, anything after the decimal. Count, and then if I add a decimal at the end.
So then you have 4 letters here. Yes.
So like
Pro.
6, it would be 3.
Can you do me a favor? Can you hand me that pro? Thank you.
There's one on the blue. And then.
Yes.
Yeah, no, you just took right?
Did you pay for it yet?
Oh, wait,
Actually, in person,
I know, John would have like the little harmonica over it. The video, right?
Okay, how's it going? Everybody good? Okay, so now you know your pros are working. So now you guys are ready for your experiment. So all you're gonna do is gonna boil water, right? So let me show you how to set it up, set up your timer. Everybody's in, you got your probe, you test your probes out. You guys, your probes are looking good?
Yeah, we are.
Okay. Your probes are looking good over there? Okay, so now what you guys are gonna do to set up your timer. Let me give you a little crash course in this.
We all have different outfits. The black.
Okay, so. You see the stopwatch here? Everybody sees the stopwatch?
just keep.
You guys see that stopwatch?
Yes.
So go ahead and select the stopwatch. Okay, so this tells us the length of time that we're gonna check. Now, we don't want to have to sit there and change the length of time. So like keep adding on to it, keep appending to it, keep appending to it. So we want to make sure that that length of time is going to be long enough for us to do our point experiment, right? How long do you guys think it will take water to boil?
5 minutes.
Is it 5 minutes?
Probably 2 minutes.
I was gonna say 2, 3.
You said 2 to 3 minutes?
Like,
Okay, but I believe that you guys are going to be using 100 mils, if I remember correctly.
Oh, probably
100 mils of water. 5 minutes. So you're gonna say 5 minutes. So let's be cautious, right? Instead of saying 5 minutes, let's go ahead and say 45 minutes, right?
Oh, okay.
So we're gonna say 45. We're just being safe, you know, because we don't want to have to see, keep adding to it, keep adding to it, keep adding to it, right? Okay, so now we want to have it set up so that it'll sample after so many times, right? So if we take a look, the sampling rate means it's going to sample 1 sample per minute, right? And then you maybe not want to do 1 sample per minute. We may want to do 4 samples per minute, right? Which would mean every 15 seconds, right? Because how many seconds are in a minute?
60.
So if I do 4 samples per minute, then that means that every 15 seconds, it's going to take a sample. Now, it's going to take a temperature point every 15 seconds. Now, you guys are talking about seconds and minutes. Is that going to be enough? 15 seconds, or do you guys want to do it in 10 seconds?
We gotta do it anyways.
Do it every 20 seconds? So you want to do it, you want to just make it hard. So every 3. Right? Okay.
Oh,
Now,
let's do 4.
Let's do
let's do
4.
4. You want to do 4 to be cautious?
Maybe 5 now.
Okay. Okay, so then you want to go ahead and hit enter 4. And you're going to hit done, right? So if you have 2 probes, it should show you both temperatures. You should see both temperatures on the side. I don't have any probes added onto mine. You should have time. You should have temp 1 and temp 2. Okay? Everybody got that? Okay, perfect. Yes. Let me show it. Okay. No. I don't too many things today. You guys use the thing on. Need batteries? Oh, you don't need batteries. There's gonna be a power. Power supply.
I asked her this last night, 'cause I was like, oh my God, I charged you my homework and it's all you need to pay for. $35.
I can't do it until tonight. If I go $35, you'd be like.
If I do $35, I'll be like, here's my $2 out there. My boyfriend's like, I only work Saturday.
Okay, so you'll also need a.
Oh, this is like a
Hot plate that also turns. So we're gonna go for 2. So all we're gonna need is. So you're not gonna need aspect of it. So each of your groups should have a hot plate.
Yeah.
And see if I can find one more hot plate.
What's another
Hot plate.
No, I got it at first. I want to get a white card. That one might not hurt here, but there's not a lot.
Because there's a lot of us. My mom has it right. Yeah. Yes. At all. And I'm surprised it's in there either, because they're like rather. Yeah, I tried it out.
Okay.
Get one next. Yes. Yeah, no, she has them like right here. Just home sense.
Oh, yeah.
So you know what it's like the center
Yeah, like it's down there.
This is my grandma.
Okay,
I
so
wanna
you're gonna
try
need
kids
your
right
glass beaker, 250 ml beaker, and you're gonna need distilled water. I mean, distilled, each new wine, 250 ml. You should have, there should be one. The one right there, that says a note.
We're using glass? I don't really.
You guys do
So we're gonna
and you guys station one over there.
well, that
Okay.
is 200. And this one.
Okay, everybody got their beaker? Okay, so what gear are you gonna need for safety?
Our PPE, our lab coats, goggles, and gloves.
You're boiling water, but what could happen? You could break glass. Something could happen.
Gotta get dressed. Gotta sit up.
And what should you do with your beaker before you get started?
Make sure it's not broken.
What was it?
Get dressed.
Make sure it's not broken. You should also get dressed before you, if you're coming naked, that's a problem.
Almost.
Almost.
I was rushing on the.
Is it working for you? Still update.
I really didn't have it. I'm gonna still. I have my glasses. Or my regular glasses won't work. Oh, then I don't. Also, I have to go outside and get my glasses. I have my glasses in my car. You told us to keep them, right?
Then you can use mine.
Oh, they do fit over.
Yep. But I lied.
Yeah.
And they're actually adjustable too. They extend further out and
Really?
yeah, and they'll move up and down.
One size fits all.
Should.
Oh, that's cool.
You guys want to get the hot thing ready? We're gonna boil on that.
I am 4 eyes. today. Which one? What were you?
That blue thing?
Oh,
Yeah, everybody has the heater.
Who goes to graduation?
You're taking a video over here, you. Oh, show me that video. Yeah, working hard today. Like, we get a job done. Oh, you gotta, I have my jacket
You just came with that one? How old is your daughter?
So you
oh, these blocks.
Yeah, from
Damn, why is it so big from here to that?
Mine probably like
Okay, probably like 29, like if not 20.
It's like, cause you're over.
Well, but the warm.
Maybe that's
Did you?
Isn't it doesn't have much more than one? I had my MacBook to share.
Or I just like it and I really got it.
I'm surprised it's not tiny like this. I would expect them to turn it more tiny.
It's not on plug in. I do have plug in my bed, but it's like I covered it. Yeah, I just did that one.
That's great.
That's
Like that. I've had it for like this for a couple months already. Like my son, he was like,
I just got my phone.
oh, I had it for a whole year before he cracked.
Oh, my.
I was
so mad. I was at work. We were buying both of them. And the lady goes, "How do you see this?" Like, so I'm doing that, but my freaking phone broke. Like, okay.
I used to work in the intern.
Oh, like that's what I can have. My phone, because I have my computer like this. So I'm doing my phone. And she said, "Excuse me," so I split wherever I record. And it's just like, oh, and I was like, oh, yeah, this is the way it sounded. I dropped it off.
It was so my iPhone 10 was good until I threw out my iPhone 10.
Knows with the phone.
And I went and he wouldn't have moved, it would hit his face, but he moved and it hit the wall and it was like shattered the front end of it. I'm not toxic. He threw his phone first. So what's the complication? Conversion? There's a lot of conversion, what you get. So what he got, yeah.
No, I asked him,
You're gonna crack water phones.
God.
it's on TikTok, look on TikTok.
Yeah, just
It's just that was back in the day. That was like before kids were toxic.
oh, this
It's years. I know, girl.
That's why when you were like, oh, here's your headline.
You gave him a 0.
I just feel like he's already been through a lot together.
I just have a tendency to kind they're not talking about like people that have that. I was on the road, like, actually, we don't want to get that off. If they want to travel first. I don't know. She's actually. So if it comes before.
See, after my kid
measure 200, we're gonna measure 50 here, and then 40. I know, but I can tell you, like, with the map was it one, you know what I'm saying? I feel like super.
well, talking about baby daddy.
And he said it holds 250, and I get that, but like,
up until, you know what I'm saying? So we'll make it exactly. Yeah.
Oh.
Just 100. Yes, it's,
Right here, we started
Oh, no,
with the speaker too.
I'll try that. I'll need a little bit more.
Wait, so now I can put it on. Yeah.
Oh, you're right, because you think all we need is
well, you have to pay 100.
Oh, I'm scared of it, guys, I don't wanna have no more kids. If I leave my mom, I don't want more. I don't want another baby.
Oh, that's just on the materials.
Yeah.
You don't want to.
I don't even want more kids. Oh, I wanted to get my tooth fed. Just put it in here, just pour in the water.
You're just like you're here.
Do you make sure it was cracked? I'm so big of a person.
If you graduate a year ago, the fall still makes sense. There's 4 rooms, 100 ml of water, into 250. So only 100. Okay? Into the. Yeah. As shown in figure 2, place the beaker on the top. Oh,
Should only put one inside first before we get it.
Check the temperature. Did you use a grading?
So you guys maybe larger.
Yeah.
Or good.
It's exactly 100.
Are you sure about that?
Place the stainless steel temperature probe. Place the beaker on a hot plate. There's a place on a hot plate. Heat it up.
oh, we don't have a ring stand. Or
You guys are gonna be using.
Okay.
Well, you're not gonna use 8, you're gonna use something just on.
Yeah.
So.
Do we turn this on?
I know, I'm sorry.
Do we turn it on? Or we have to wait?
Wednesday also.
Thermometer.
No, it isn't.
And then yours already has one, you just gotta. So you have the bar, and then you guys.
We don't have a. Oh.
What in the English one? Oh, he's getting the crowd folder. Wait, to hold it in there. Oh, so let's turn it around.
So use the other hand, because somebody snuffed something in there.
That's what she
Oh.
said.
Well.
Is it in there? Does it fit?
But we also have. Anyway, so then you're gonna. Go rest of ours. So you guys don't have to make sure.
No, I think that's
I'm not sure. This has to be on. Oh yeah, this will be.
I've never heard of that before.
Very.
I love it.
You need help, sir?
No, no, miss, you need house.
No, I was wanting to know.
Then I.
You think it's too low?
And then here's your-
Because the beaker's just.
And you got-
Are we just putting water like water?
You don't want to touch it.
Yeah, if you touch the glass, you can do
Let me get, I may have to.
that. Like, no more.
You can do this warm.
Okay, actually.
I think it's fine.
Okay.
Can we turn it on?
Turn it off.
Did we double check to see if the glass is broken? Okay, turn the hot plate on to the side.
Oh, no,
Did you guys make sure the glass was broken?
that's all right. That was my fault.
It's on the screen.
It says place the stainless steel probe.
And it says turn the hot on.
Above.
Oh, we did.
Okay, so this is what we have to add on to our lab.
Do we turn the heat on or wait?
We're not doing the lab.
You should start your.
I think we're doing a lot of this.
Oh. No, like, right here. It's the report sheet. Yeah, it's all that is okay.
I was stressing.
Okay.
First, you gotta stop. No, you gotta start there. I gotta start at the same time.
Oh, like the boiling. Okay, I didn't know if we were gonna start. Okay, okay. Yeah. All right. So did you guys turn it on?
No, not yet.
Okay, well, I think it's whenever you're ready.
No, no.
Probably on high to boil your water.
Yeah. On high?
Yeah. Oh, so probably not shake a little bit. Just have it on high and move it. So and then we'll start seeing it. I don't know if you guys want to see.
It's gonna start.
Okay. I don't know, this is something.
Very low particle.
So that's how you know it's getting hot. Oh, you have it on, that's why it's kind of vibrating. There you go. Oh, but this is kind of over there. Wait, what's the starting? 20. Yeah, no, it's like. Yeah. I guess we'll see when it goes up. I'm trying to turn, like, I'm working with the. I'll see it.
In the middle.
Or you're in the middle.
This a little bit.
I'll move everything. I know.
Oh,
And then you can put it right here.
I both of you guys speak, so we can have color.
Take a what?
Imagine colors.
Okay.
We finally got one, so we all have a color.
I have a Chromebook.
Nothing, there's nothing, like, there's, everything is different for a Mac. So you have to go online and type in some of that. How do you find that?
Right?
We'll get the new iPad.
I wanna.
I wanted to do writing pad. That you attach and then it's like.
It's like paper.
Right here, yeah. and then it's like paper. But then I was like, no, I'm bored, so I'll just write it on my notes.
Are you guys already in the group on your phone?
It's fine, I can.
No, we don't have a group chat. No, that's good. Yeah, when we-
Well, it's- start.
We can make one together.
What? It was ready to go.
Start the information by going to the screen.
Oh, yeah, it's gonna burn.
Or.
Then I do Mexican.
We all start right over here.
It's not.
Your glasses.
Last time she has it, it's like Mexican, yeah, but even if it's
No, how do you want?
Let's see.
Want to?
I'd go, yeah, it's gonna-
Okay.
Are you?
Yeah.
So we
Is it working
accidentally,
for you guys?
well, we accidentally unplugged it when it was, and then we're like, something went wrong. Okay, so sorry guys, we're gonna start. It's okay. Cause I think it just turned on. It's probably gonna heat up immediately.
It already heated. Why is energy required for boiling process? It's a pre-lab study question.
When water are zero freezing, really lost or gained by the water. How does nutritionist determine the caloric value?
Okay, you should start to see the database collection on the left side of the screen. You can stop collecting data after the water starts boiling and the temperature levels off for 4 to 5 minutes. So when it says after, when it's for 4 to 5 minutes, it makes it actually.
Average height.
It's kind of fun. Stop collecting data, return to the experiment. Right.
Why is it required to boil the process?
Turn the hot plate off when it's temperature at the right cool down before removing the glass beaker or flasks. Oh, temperature too. This one is big. Straight line.
That's
Is
the
it
highest.
high? You're using your data printout, label the parts of the graph that represent the liquid stage in like volume of water.
It's been chocolate too much chocolate.
Oh, yeah, it's all down.
Changing your mind now, how you're in a whole chemistry class.
No, you told me, what did you tell me?
Yes, I need to watch you there once in a while.
Process.
Okay.
Come on. Common sense.
So it's inside the spinning.
I really don't. I'm really not trying to rush this. I don't want to take summer classes, but I don't want to tell like science class. I don't know everybody's name. So Ronnie.
Oh, it was no.
Maggie and Jess, you can put that.
Yeah.
I just want to put it full name so that if you see it. I don't know.
Okay, so we have to.
One though, are we gonna leave it at 24.4?
You are just one.
Which just. Absolutely.
Yes.
Oh, it's the water.
You guys have it? And you have one of your pros.
What's the last section?
So, yeah. One on that.
There's no odds. No. That's just for my cashier. Oh, whatever. So your name's Margaret. I like that. I like that. She doesn't like it. She said it's all been
Step one. She was gonna be in Georgia, I guess.
I know, do you
I
know?
love that show.
No, there's no need to be. Place the beaker on a hot plate. Place the ring to stand.
If I do, if I end up
Standing on its own?
I'll take it. But it's gonna be beta or beta joule.
Oh, you're. Yes.
I'm not gonna.
Okay, let me see
marker.
about, I may have to do one
I've
more.
always
lap.
liked marker and. I have
Third
double
one.
marker.
We'll get one that works.
So-
Third one's a job. Have you started your, are you keeping track of the time?
Yeah.
You get the start button?
Yes.
Okay.
What do you mean?
What do you mean? It's good. It's the graph. It's going
Yeah,
up.
your graph looks beautiful. Yeah, but I mean, are you recording the data? Right? You guys are.
You have to hit
start.
record every, yeah.
Oh, no, that's good. I just want to make sure.
Yeah, we just followed step by step.
Okay, good, good.
So you, okay.
It's looking good.
Beaker on a hot plate. place.
Is it supposed to be cardboard?
No, like, they're saying cardboard like this.
Oh.
Yeah, we have it this. I think it's just like the.
Right now,
Oh,
You guys just don't, it's more like smell like leather green. But she said that certain smell.
Let me, I'll pull it over now, just in case, let's see.
Leather.
This is one that wasn't.
After,
I'd be like,
after. so the tax will happen when it's just like a constant temperature, like it's not going anywhere.
Let's see.
so this is like, so place, it's an action water from place to be on top. So you want to pour that, pour the water into the jar.
We have ways to figure it out. Like,
Securely.
TI.
Oh,
That
Yeah.
is the wire.
TI, what did you write down as initial? Celsius.
I don't think.
I trust you. It's not you. It's.
that like the gas. No, not the gas, it's like the soap.
Make certain.
She's like freaking burnt. That's what it reminds me of when Tracy's from that's what it smells like. I felt it.
I hate electric stove too, because like, what if the lights go out? I have to be.
I hate that it's not hot.
You
So
remember?
much stuff, I'm like, dude, I know you guys are trying to dinner, but if the lights go out, I'm not gonna barbecue, so you need to figure it out. What will we use on my fireplace?
Those are pre-lab study questions. Oh. So they're just like, oh, pre-lab, yeah, before. So we're studying it oil. When did this? Yes.
24.
Have you guys seen that plateau?
It says more energy is required, energy present to it. The more energy can make it allows molecules to pass through branches separate from other molecules.
It's not there yet. Whenever you'll see it's like a straight line. And then that means definitely.
Yeah. That's what I was just looking at. Yeah.
I see a lot. I think it's boiling.
It's seven.
It's heat.
Yeah, man.
There's steam.
Okay, yeah.
There's steam. Look.
No, you're supposed to start.
If it doesn't.
But it has to be boiling for 5 minutes, no?
45.
It's been going already.
I think, oh, we were all saying, I was in 1 minute.
Right here. On the side.
This one.
So what I do is just append it to the guys that you have.
So
it's a bit
80.
different than what you guys are getting.
It's a little 7.
Because you guys did not.
What's your change?
Oh.
Oh, the volume.
Yeah.
So right here. So 82 is one time.
So we're gonna wait for it to like actually bubble the whole thing.
Yeah, and then it said it has to be at a plateau. You'll see it straight line. In the same temperature all along. It says when it's at the plateau for like 4 minutes, then we're done.
Great. I see some movement.
So you're gonna have, yeah.
You're not boiling water?
Oh, it's because.
Huh? Oh, because you guys. You're in the stove?
It says.
Oh, yeah.
Is it not recognizing the verbs?
I know, I was like, I got that one again.
So we have to
what's
watch
the-
it from like the last couple. And then we'll figure out the temperature change. Do that at the final.
But you put 7.5 days.
It's at 7. That's what it
That's
says.
fine.
Oh, to 60. Okay, to 60
To
degrees.
60 degrees. Yeah, you'll see it right here.
I just wanted to double check like what. I was like, I know you guys said we'll put 750. but what? This is so hot.
I feel like,
Did you do it again?
I'm out. You want me to say now? Go on.
I just say like regular English. But I
No, I put it in the middle.
You can tell some of the water has been evaporating.
That felt
Someone stop, you can record it like it's there. No, I know, but I'm talking about again.
Oh, I don't know. I think we are for the tomorrow. Yes.
Oh, look at see when the plants are.
It's starting to boil at
The water starts to boil.
1325. And 92. 91 inch. 91.
Oh, look at my granny.
Oh, I don't even care.
It's because look, if you guys do this,
It's
so
heck of
like
a
you get like a.
Third one's your time. So I have to-
Yes, sir.
Going down. This is literally like by a millimeter. By a millimeter.
But the thing is,
A little bit.
yeah, the thing is that. Next month. And stay here. No, it's on Friday. So if you say I would miss a work, a day of work. What do you think? Stop it, is it really right now? Yeah.
It's like standing up.
Like that.
You didn't know that movie thing is stretched by that. One day.
So it's like the other.
Really?
Yeah. So then it's 4.5.
That's what my baby is. They're just standing up. No, they keep on coming.
You know what this reminds me of, bro?
Stop and look at them.
It's called like the different sessions. It's like you know like how they make like the shirts.
Oh, no. It's all like that. I'll fix them in the car.
And then Dutch, are you gonna do
Fingers
so
crossed.
many of my friends?
So it's gonna start like flatlining.
So it's
And I
just
told
going
her,
to 7.8.
It actually started falling at 91.9. But
Oh, like slowly, yeah.
yeah.
It's like a
Oh,
rapid boil, I guess.
well, rapid boil is 95 or whatever it is. Whatever it is. But now it's
The
rapid.
thing is, me personally, if I had choice.
No, that's not the thing.
I think
Yeah, boil your water.
it's like the cups, or like.
This is
Well, 'cause you
boiling
have a
enough to
bigger-
make a
you have
soup
bigger
pot.
cup. Yeah.
I can make a soup with this.
I think that's as big as I'd rather.
It's going down. Like,
You see the bubbles in the middle. I think we should do that. Yeah.
95.0?
Yeah.
No, you just calculate it from where it starts.
You can make a Starbucks only. And then you go.
But don't you get like a lot of like dip and stuff like that?
Yeah, but they do like yeah, they do. Is Dutch is 15 plus 10. You get these too.
No, but you get a lot of like, like benefits.
Yeah.
Like IDS 45. They'll pay for a lot of things for your life.
But it's like,
They're good companies.
and then beginning my drinks, I'm like, oh. And then like, here. Like, so like, when it was
That's smart. But they have a little.
we're gonna let it go. They're boiling already. Oh, that's a platform, so what, what is it?
Where did you put green tree?
I think the plateau's 95.
I don't wanna waste time, you guys wanna get. Are you looking at my hair?
No. No, I don't know.
I'm so scared that it's actually gonna go.
No, it's fine.
No, I should.
Now it's like going down. It's like 95.
It is. Weekends I do, but for the week, I need to rush it out. Especially lately.
Well, we're doing part A right now?
You're doing part A right now,
Yeah.
and then you're also gonna need the second, right?
Oh, okay.
And the ice is in the sink over there.
Okay, okay.
And then you should have styrofoam cup.
Okay.
I think we're good to turn off.
What?
Yeah, just one in the room temperature. and then one in temperature. And then- Pop up here.
So you have to stop. We should have waited before starting. Water's been on.
Or can we just change emulsifier?
Oh, there's 1 minute. Yeah. Imagine if Boston was at, like, a certain percent.
I think just shakes it.
Yeah.
I'm gonna go get another beer.
Oh, we can ask them how it is.
No, it was a third. No, drop the second.
When it gets to a certain temperature, it goes to the stage. It's gonna stay at negative.
You went down.
Is that 98.7, that's okay? Dr. Henry?
What was that?
98.7.
90.7, okay?
I mean, it's supposed to be 100, right?
It's actually 100, right?
It takes a long time. What does it take? I understand, so this is a reference.
No, it wouldn't get to it. But I know the boiling point. Yeah, it was okay.
You would have wanted to get to 100. It's literally staying at 95. Literally, it's like bouncing off.
We had a boiling.
I like getting for like 5 minutes.
I know it's a process.
I just know as soon as from the point that it started boiling. From the point that it started boiling to the time that it just started just staying consistent at the same temperature.
I think the highest was 95.6. Oh, yeah, you're right. That's it.
Doesn't start at 15. After it started boiling, we had it boiling for 5 minutes and stayed consistent.
So there's no way we can take our exam on paper.
No. You gotta get used to it. This is the way the world is. Don't fight.
That's what I found out. Yeah, you just taking a practice.
That is easier.
You don't.
What?
She can't have any noise or anything.
I know, but it's like, green screen, like, that's a lot.
What's a proctor exam? What's a proctor?
So basically, because then you have to show your ID and then you have to do your voice and then have to check your connection and then you just share your screen. Anything that you do on the screen, they'll be able to see. And then on the side, it'll flag if you like to on too much or if you hear talking in the background. And sometimes it'll say scan the room. And you just pick up your computer and show them. So make sure. Yeah.
I don't have an ID though. I'm gonna have to go somewhere.
Yeah.
I don't know where to go.
The proctoral scene until Sunday.
Yeah, I know, but I can't use my computer, but I can use it in different classes. I can't use it on my library. Don't you have to download something like a laptop? Don't you have to like download like a lockdown browser?
No, lockdown browser.
Oh yeah, that means you can
Proctorial is
only-
yeah. Lockdown browsers you can't go. It's read what you want to. Okay.
It won't
Number of calories needed to drink water. You say. We're just trying to make the water go
Like one
away.
bowl.
Because like serious.
Yeah,
Water
here.
specific, yeah, 100 calories per gram.
I know.
Well,
Yeah.
temperature.
I did 70.8, and then there's 100 water, and then for 1 gram, the ratio for
Oh, because yours was already before.
from grams to ml is 1. So you have 100 grams.
So we can get the master water.
Yeah, 100.
The master water.
Because you started out with
And then
your hot take.
The gram.
it's already right there.
Oh, yeah.
100 ml times 1 gram or 1 ml.
You probably, we could just-
1.00 grams. Over 1 ml. It is the equations up here. Number of calories to water. We calculate the use of calories. And calories used to make the water the most calories. equals more than
What's that? That's a bit.
Oh, so that makes it.
Okay,
100 calories.
all right.
I see that.
So
See?
to find the last part,
You can sit right next to you.
the number of calories needed to be in water, the formula is calorie equals the mass of water. Oh, times. Let's see, times 1. Oh, that's what we showed earlier, right? So the equation was, what was it?
So it was MC delta T.
Well, you never really started. So never really started.
So there's 70.
Okay, so then you're gonna get that again.
So there's 100 grams, right?
Starting over or pinning on. Yeah, so you raise, yes.
That's good.
Difference, right?
Yeah, so times
Yes.
It's,
Yeah.
oh, calories.
over what's grams?
Yeah.
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 So check.
And I thought it was.
Oh, okay.
Did
I was
you guys
trying to
get
do way
7,000
more.
or
7,800
calories, right?
Okay.
Oh, but how many sick days did you turn?
3 or 1. Which one? 3.
Was it 45 minutes left to stay with this?
So then this one, 2,
3.
3.
All of our other numbers have 3. Yeah.
So it's been 7.08.
True. So
Right.
how was he doing it earlier on there? Remember he did the math and he goes, if you have one.
So 0.08 times
What's the
3,
answer?
like that.
When you rounded that large number.
Like this,
Those.
times 3, times 10.
23.
Okay, so it's 10.4 the last time.
Yeah, it was 10.4.
10.4. So when you
280
move it over
times
the
10
decimal 1, 2, 3, we put 10 times, we put times 10 over 3. Well,
Yeah,
10
but last one was
exponential.
Okay. I think also
As my, that's how many calories, right?
Yeah.
So 7.08. 10 to the power 3.
There's not a point.
Yeah,
No
we
point?
have to move it to push it.
Oh, yeah.
You guys can raise the point. Wait, but would it be a negative?
Is it negative to the left or negative to the right?
Yeah, if you're moving that way.
We're moving this way, it's negative?
Moving that way, probably.
Yeah, so it's negative. So it's 10.
Well, you didn't read it last time you did.
Wait, what you talking about the one with the? That was
Yeah.
no?
Oh, you have it written down. You have that. No.
I know, I want to see.
Energy and matter and. So you guys want to save your data? I'll show you how. Okay.
Well, we didn't have it, so.
It'll save it, yes. It'll save to the PC.
I know, but he makes a decimal.
No, well, that one was already this one.
Okay, so you can go ahead and save it, save your data. This will pop up. So you guys probably want to call it energy and matter and your initials for your. Okay, now it's gonna save it as a logger profile. That's the first thing that's gonna save it as. So we also want to save it as. So after you've done that, that logger profile, you also want to save it as. Go down here and you want to export your data. So if you export it as a CSV, this will allow us to use it in Excel. So we're able to recreate that graph because it'll have all of the data points. And so what you would say is energy.
Well, you have to say computer.
Matter CSV file. Right? And then your initials.
The keyboards are harder.
Okay. And the data itself, you can have it print the graph that you have, you hit print graph. And then here you're going to save it rather than printing it out, just save it as a PDF. So you have the option of saving it as an Adobe PDF. So then that way you have a PDF of the file that you want. You hit OK. It'll ask you what name you want to name it. And the Logger Pro is going to run really slow because it's translating it into a PDF. Funny, the instructor camera recognizes him as teaching. You're the instructor of the class today. Start teaching. Yeah, that's right.
Right, you said it.
Okay, how's it going? Yes. Say PDF instead of saying printer.
It says print, then it says Microsoft print PDF.
Yes. Yes.
That's the
I
fine.
forget yours.
Where are we saving it to?
You're saving it on the computer, but you're gonna save it as a PDF. So you can, which one did you save?
This is the PDF file.
The PDF file? So you can save it on that computer itself. So just put it under there, put it in documents, and then email it to yourself.
Microsoft. What should I do?
Like after my student gets used to it, I felt working. That's what I did.
The orange thing was.
It's blue. After you get
Oh, yeah.
it,
What I use.
The keyboard.
But I wanted this because my skin is even breaking out.
Well, I use I use 5 minutes.
I got some.
I use Google Patches and then when I do my makeup and all that, I use.
So did you get plaque?
I clean my face
That you
with
want to keep
the
on it?
water.
Okay.
I clean my face and then I add the ordinary. And then I use a hydrate for hours. And then I put sunscreen. And then I put like outside.
Okay, everybody got their data saved?
Oh,
Smiley saved?
That and the. Yeah, but how did you get to the point where you sent it to yourself?
You email it to yourself. Just go into your email. and
From
email
the
it.
like right here. Oh, me.
You were putting.
I always use it to check the habit ounces and I'm not writing. And with gum.
And then you tell me.
Yeah. Oh, because last night I bring it. Oh, because last time I was like, when I'm.
So I read it, it says.
Dr. Nicholas.
Seven or the morning?
I worked last night, so.
He offered to drive it.
You offered to drive it?
Okay.
And you're still gasping.
Oh, you got it.
Well, that's her right.
How's it going?
Yeah.
Okay, so did you guys do the second part?
Well, we're still stuck on trying to email that to ourselves. And then.
So you're probably.
It's like, okay,
Yeah. We're tired. It's Monday and you didn't bring us coffee. All you brought was ice.
I brought ice. It'll keep you awake. Let me put it down your back.
I'm one of those that likes that.
Really?
Yeah. It's actually cold today. Well, I'm cold. No, I feel like.
Okay. How's it going? Everybody's good? Everybody got the data?
They sent to you. Okay, you could just send it to us. Oh,
Send it to yourself. Right? Oh, sure. I'm sure you can take it off the charger. So you know the one, right? I'm sure that would off the lockbox. Like,
Okay, you guys got the data? Okay, so you guys need the second part.
okay, second part is. We're done with this? Yeah.
so she sent them.
The second part. Well, no, I think this is already.
Oh, yeah. Yeah.
So Wayne and the styrofoam cut in the ground. They gave us that cup. Huh? The empty side.
Wait, so why do you have a? What? Oh, no, no, she put the decimal.
No, I didn't, only because.
Long as you keep track of the number of decimals.
No, so we have to measure ice.
I'll put on the side just.
So the title 2.0 grams now. And then am I just clicking send? You already attached it? Oh, there. Wayne and the styrofoam cup. We're not gonna go out. The way this is.
I've never heard anyone else have like.
So is it impossible?
Record the initial temperature of the water. And the.
Okay.
Yes.
I need help.
No, that was right, it was one.
Look at my.
Was it you or one? I for one.
Because,
Would you give her the A6?
that's it.
It's one or is it the actual we got?
So, but it comes down to.
Oh, she changed it? No, she never got it on there. I thought it was supposed to be. That's only calories in 18 hours. We literally looked at it over here. Like, specific to the water, 1 calorie. Water is specific to 1 calorie per gram.
I'm pretty sure it's like how many calories would it take just to keep our water? Heat this one. Heat this one. Should we ask him?
Yeah.
Okay, that's all I got.
I guess so. Wait, was this one or was whatever you did? I put 7,000. Okay, you never one.
Formula to find that is on the back. So the max, the calories, the max in water. 1 calorie per gram. We did that.
Okay.
Oh,
So now.
how long did it take for the temperature to rise to 7 minutes?
So you want to go ahead, yeah.
That was very simplicity, right? So the instructions are literally right here on that. Part B, it says to weigh an empty sacral cup in grams. It was 2.26. Add 100 milliliters of water. So
You're gonna get a new graph.
well, it says use a graduation. Oh, it says 100.
Yeah, you're gonna, well, we're gonna also say a couple more things. We're gonna have to say the picture. We're also gonna say the picture. Okay, so what you're gonna do is go back to the, go back.
Oh, you're gonna
to
do two?
Go to file.
It says 100.
That was cute.
So
Or
you
should we
want
just
to export. And then you want to save it as.
add 100 water? Oh, with the graduated. Oh, that's when you
Like,
put your
all of the
bigger
data
one.
points, we can play with
Yes,
that.
we'll grab the bigger one.
Yeah.
Yeah, you don't want to put your styrofoam cup on
The hot plate.
the hot plate.
So no, yeah, just use your second one and we'll.
I'm just saying, right? We want to use a little common sense, right?
Oh, definitely. We put it on.
On this? No.
And then you wanna get-
No,
And then you want to say this, yeah? Uh,
Those are plastic, the bottom.
Oh, they think this is
You
far.
guys want to tell me? That's what we want.
You're supposed to put another 100 milliliters in the styrofoam cup, not in the hot- not on the
I
hot.
can't see.
That-
A little bit more.
Yes,
Like
you're done with that. That was done. So you can move your hot plate over, so your hot plate's out of the way. You don't need your hot plate anymore.
And then just said this right there was the.
Underneath, yeah. Yeah, but not on the hot plate. It'll say Microsoft. Yeah.
I love her more than dot.
Yeah, just like a little drop. A little more.
A little more dot. Half dot. Okay.
You guys are doing under.
Under the
Yes,
meniscus,
right?
yes.
You said more or no? Like one more dot? Yeah, like a little bit more because it's a bubble.
Yeah, free documents. That's right.
I forgot that.
Yeah, yes.
Oh my God, playing Alina.
Because otherwise, stay there.
Okay. So we're going to. Okay. And then reweigh the cup.
Oh, that's important.
Whoa.
There's a
Water's
green.
like yellow.
It looks yellow and
I think there was stuff in there. That's the best.
And there is.
this isn't water, y'all.
So.
Was there a washing it?
Okay, so then she's gonna reweigh it.
I'm just saying, you do what you want to do.
So we can, I'm not sure if you explained it, but we can just take this out and use that one, right?
That's
Okay.
Or you can just take the one that you have in temperature, put this one at room temperature. Right, and then you can
But
use the one
opposite
that you
side,
have.
right?
Yeah.
Okay. I don't know, I'm not gonna catch that.
What's that? The other one?
Oh, that's all. I'm gonna lower it.
97.2690.
Okay.
Initial water temperature in it. Oh. Well,
Well, that works. Oh, well, that works. Your phone.
Not yet, I just want. So this is the second one. I think it's gonna take this one to consideration. So wait, it's- Yeah, we just need to.
You have to measure the temperature.
Yeah. So the initial temperature is 24.5. Add 2 or 3 ounces of water.
And then measure it.
If you guys just right there, just throw 3 drops right there.
Oh, so we're gonna stir it this time. We're gonna stir it.
So I'm just gonna stir it. Because you have to stir it around till.
And two,
Without, so we put 24.5.
check temperature underwater.
So when you put this in.
You can start with that?
Yeah, you can actually.
Where's the lid?
And so keep adding ice.
You have to stir it with the lid on.
Oh, yeah, that's what we do. So we're taking this out, right? Okay, and then it's just saying just start with the name, right? You have to go over and then.
How's it going? Everybody got their cup? Everybody got their ice?
It's just not to add more ice until.
Okay, so stir vigorously. And then we're gonna check the temp on the ice. Smells here, feel like it is watery. Well, you can hear it.
No, get fresh water.
After big, I don't know. He's so behind. He'll tell us to be quiet. I really read chapter 10. But we're very.
I don't want to put the paper. It's gonna be in there.
Yeah.
The ice is melted.
So we're basically gonna.
Because you know when you started out.
Oh, do you want to leave a little? Right, leave it over there.
Okay.
Oh, right.
Just don't want to stop it.
Oh,
Okay. And then we're gonna wait for it to dry. Okay, so. This is 12.7.
No, it's really long.
We're gonna add ice
The bottom.
until it drops to
Oh, shit.
3.
Go get some more ice.
Yeah, it says check the temperature of the water
How's it
when all the
going?
ice is melted. And then you start adding.
You're gonna add more ice.
Yeah, do I take it out and then? You just add it.
Add ice, we're just gonna add it.
If it's gonna be down to 6. And then
It's
go
some
on
ice,
and
it's
less
not
ice,
most of it.
less melted. Yeah. Oh, you're right, so let's just let it drop down to 2 or 3. And now let's take out the ice.
Just open that down. So,
Oh, it's dropping.
Now you get to use,
I think it's melting slowly, because I didn't, I'm not shaking.
I'm working on
And also, you know,
But you guys
the
can
ice
do
could be on the thermometer.
Okay.
That's right. It'd be nice to have.
Another ice.
So we're not having
This was it.
That's right. I like to allow it to twice as long as you should.
you just write it.
Yeah, I'll tell you what you need. Yes. Yes. No, I'm tired of less water.
Use conversion.
You mean density, right? The density of water. Did you talk about density? Did you talk about density? Which is grams per, right? So the density of water is approximately 1 gram
Report the final
per
temperature.
mole. So the density of water is 1 gram per
Oh,
mole.
yeah, it's reports every.
So then how many layers is it? So if the density of water is 1 gram per milliliter. So then how many? If you have 62 milliliters, how many grams? So now I want you to write this down. So write this down for me. So the density of water is 1 gram per milliliter.
One down. Oh, one down. 140. The report every.
Now, if you have 62 milliliters, how many grams? That's
We're gonna leave all the smoke and pigs until after.
500, right?
Yeah.
You put that in there. Right, I hope it will go up. Right after. It goes up under the
Oh, you know.
No, actually, it's there for.
I want to make sure. It's
Wanna go away?
Get a very.
Wanna go away?
This
Wanna go away?
Yeah, I was gonna say. It's just easier.
You zero it out.
Yeah.
Oh, that's the right there.
It'll warm up, yeah.
When I grab it.
Yeah. What you could do is, get started with just. We have plenty of water, you know, usually I'm running out of water.
Well, I don't know.
I think that.
I said we need a break.
Oh, the initial one.
Right.
That's part of the experience. I think the water is,
That's the part, Travis.
that's, you learn real quick, right?
Water.
Okay, when water at 0
So maybe when you
degrees
graduate, so-
Celsius, is heat lost or is heat lost or gained?
You can use water in the room cup first and then, you know,
If water
yeah.
at 0
Yeah,
degrees
you don't
Celsius
wanna-
freezes, is heat lost or gained by the water? Lost? Heat's lost? It's on the pre-question.
The rate exceeds 2 samples, the maximum distance exceeds.
How does exothermic reaction differ from an endothermic?
Okay, you want to go 45 seconds.
Oh. Okay, there.
I think that's.
That's what you guys did.
Yeah, and we just subtracted them with the-
Device.
2 or 3 chucks.
But I thought it was like after that, we have to add ice.
Wait. You should need to- oh, you gotta start. Vigorous. Is that vigorous? There you go. It's like making cocktails. You don't just. Nice stir, right? Oh, these, no, that's the problem. Okay, that's the.
Oh my goodness, okay.
Will you go with this one? This is like great, so two.
Yeah.
Yeah, that's how we live here. You're gonna learn so much from this class.
If you're saying error, but you could just supposed to use this little thing. Like yeah.
Yes. Yes, this one does right.
But then it's like.
Yeah, so you guys are gonna use. So that's what we were discussing.
Yeah, that's what I heard, yeah.
We're limited by.
So, yeah, that scale over there maxes out at a certain point. We have to- So, can you get the little scale in there first? Oh, you're natural.
With the video,
I'm gonna, like, barely, you know?
I said. Yes. What was that? Can you explain? It's insensitive, you know,
I would have, you know, take what else. You can make all, you can make a lot of stuff.
So we just wait
So how you-
a lot of things.
You just be sitting at home making stuff.
No. if
I
I-
think it's gonna tell us like
So what I have to do
the
that
water.
time away.
Never seen the
So
show
when we,
before.
at first we measured the water and just the stuff, right? And
Never seen
then
the
the last edition we worked with ice, and so from the different each size, you know, technically.
There's a lot of
So you think that, you know, give us that, we know about it, they make on their own.
There's been, which was the first paper?
Well, I know, but like, what I'm saying. But they can die trying to.
Most smart kids don't test it on each
Oh, 2.7.
so that they do.
So the red is like.
Yeah.
Oh, yeah, my house is there. Oh, yeah.
Okay, how's that ice going?
Yeah, but if we didn't do that.
Okay, how's it going over here?
How much did you go?
Okay. You guys already got the ice? Okay, so let's start again. So you guys like to make it hard, don't you? You're like, no, we can't. No. Everything has to break down on it. You gotta break the computers and then we're gonna make it hard. Okay, so let's go ahead. We're done with that. And then, well, yeah, you go get 100 mils.
There's 100 grams.
Right here.
So you pour out that one. So we're gonna
Subtract
subtract
B1 from B2.
So then that. Hey, how's it going over here, guy, ladies and gentlemen?
It is going.
It's going. You got data?
This is for our ice water.
You've already done it?
It's 91.
Negative.
Negative.
Yes. Wait, B1 minus B2?
No,
Or
B2
B2 minus
minus
B1?
B1. It says subtract B1 from
So
B2.
it's negative. 90.
It's a little bit weird.
And subtract B1 from 2. So from
We'll work on
27.2690. Subtract B1.
Yeah.
Right?
What?
You're subtracting B1 from B2.
Okay, so you start.
Let's start with B1.
So you want to restart that, make sure that's set up right, and you see what the data points.
Well, then it's 95. It's 95. It's 95. It's regular 95. It's regular.
You want to start off? Okay.
I just thought we were minusing actually B1 from.
I get what you.
Because the way he
We're
worded
making
it.
it a negative, yeah.
Okay, so
I
now
don't.
you're ready to start.
Because the way he worded it, but it makes sense that it's a positive.
And it's every 10 seconds, right?
Because we're not taking out any mass, we're adding mass. We're adding water.
So the starting temperature was
Yep.
24.
No.
Subtracting 97.2390 by 2.261.
And then it wasn't safe.
Oh, we have one of those.
Oh, yeah, no, that's
That doesn't mean
I don't know. Wait, for what?
You're subtracting B1 from B2.
Yeah, but what do you mean numbers? Then we have our numbers.
Oh, here.
Good job.
For B1, guys,
Yeah. Oh my god, it was 27. We put 97.
Oh, I was like, where are you guys getting these huge numbers from? Oh, like, it's 25.
Oh, wait, you put 97. They were home.
It is 97.
It's like a seven.
Yeah, it's 97.
Yeah, it's 97.
It was 97.269.
So we're right. Well, the point is that we all have to like the same answer.
How would you
Yeah,
calculate?
us three got it. So 97.
Okay, you tell me how much.
Yeah.
That makes sense. So if you get frozen, how do we add that much ice?
So you have to get that.
25.00.
Yeah, that's all like.
You probably-
I don't know why I brought it down. I cannot.
The temperature change was. Oh,
Would you do it by that?
yeah.
No, because for us,
24.5 minus 3.0.
Yes, that's what it was water last week.
Temperature change is 24.5 degrees. 24.5 to 3.0. 21.5. I bought a calculator.
You bought her a calculator?
I bought a calculator, yeah, but I looked it up.
You can get one at the 99-cent store.
I bought it.
They used to be $1. Now they're like $3.
I got the scientific.
Scientific. Oh, you got the high-end scientific. You can get it for 99-cent too. I'm not kidding. It works fine. It works just fine as a scientific. You know, we're able to do all of
I guess it's
that.
hard because when they get back in the house, and I'm like, why do you have to charge it? Well, it's because it has like the color graph.
It's a graphing calculator.
Yeah.
I like it.
It's 84. It's not
So-
one, but it's like the color graph.
Take the time to learn how to program. So when you take calculus or anything like that, then
Well, yeah, because this is something that, so like I can connect it to my computer, so whatever I do, my computer on my computer. Sometimes.
oh yeah, it's nice. It is nice. It'll cook for you too. Boil water. Okay, so how's your experience today so far? Boiling water, guys? We can boil water, right? You got that checked out, right? And we can melt ice.
I know. I'm sure it would.
We have no trouble with all that. Right?
The calories lost by water.
I think, yeah.
So there was like a memo showing like how many. So did you do 95.0069, 21.5?
Yeah.
2042.64835.
You guys have questions?
So your time thing?
Yeah. This is when we have to do the. Remember how we did the last equation?
Was it talking about how much?
Oh.
How much ice?
When you get a wrong answer like that, you have to.
Oh, don't forget, yeah, that's what you need, this whole thing, the like the 10 to this problem.
Oh, because we have it in 366, so to be honest. So it's gonna be 204.
Well, this one. This one. Oh, because you're going from a-
You said what?
Your island to me, right? Yes,
Magdalena? No.
Remember?
Well, yeah, I think you said it right. What did you say? No, in Creole, it's Magdalena. Magdalena.
That's how you say it.
So it's gonna be.
Because remember, it's final and it's finished. Your final temperature is
So
lower
it'd
than
be 2.042.
I think it's just 2.04.
2.04, yeah. 10 to the.
you guys make sure you get everything in the box. Last time
Would be negative. No, I don't think it's
Okay, so your final temperature was it lower than your initial temperature?
Yeah.
Your final temperature, so should that be a negative value? Because it's in a final minus initial? When we calculate our delta T? I'm just saying, I'm just saying.
I was telling you it was negative, but.
Yeah, you weren't saying why, you were just saying.
She
No,
was just
because I was
yeah.
saying, because we were minusing it from.
Yeah,
I was saying it'd be one
You-
by one from.
I feel a little tension
She
here.
was just saying it's negative, but I couldn't understand why she was saying that.
Because we're minusing
it.
it from final.
That's right.
Yeah, but we don't have, so is it -3? Is our percentage -3?
No, you're
Yeah, that's
the change in temperature. You're saying you're changing temperature, right?
Was -3?
No, but that's your final temperature. It's 3, right? So, but when you calculate, you're talking about when you're calculating the calories. How do you calculate the calories?
No, I don't remember.
It's that equation, right? If you use that equation, you
Yeah.
use the delta T,
Yeah.
right? So if you use that delta T, right? So then that delta T should be a negative value because it's the final. So your final temperature was smaller than your final temperature was -3, right? That's right. Yep. And so you put a negative, right? In front of your calories.
Oh, so
Yeah,
she was saying.
you change the temperature, she have a negative value there. Yep. So go ahead and put a
Okay.
negative value. That's right. And then when you use this value, you were using a negative number to multiply, right?
Oh, so then it becomes a
This is
negative.
a
Oh,
See, good job, good job.
yeah.
See, that's why you guys work as a group. You guys discuss and you argue a little bit, feel a little feistiness. That feistiness is good.
I wasn't feisty, so.
It's not feisty?
Wait,
Oh, okay.
no, but she was saying negative instead of -5.
So it's
No, but I was
just
also
like-
saying negative here too.
Oh,
So
okay.
I can.
Okay.
Yeah, but.
EO, that's okay. The value that is was.
Because it says EO, whatever.
What do you mean put
and
negative
then
number
like
to
one.
the
Yeah, because you have any time, it's 5 negative.
So let me see. Because you're talking about.
She was saying to the 8 power.
I think we were going from. See, so why did you write 4? 'Cause I would say 8, but it's that's not. It's 4? Well, no, here, so I think from. That's what I was thinking.
Girl, you
8 was
happy?
1, 2, 3,
Girl.
5. So
I would
this
say
one.
5.
Drop this
That's what it is
car.
on here.
But
too.
since it's a 1, it's a 3.
Okay, Jody.
But right here, look, the answer here was 2007.11. From right
I'm gonna
here.
send you a picture of
One,
the
two,
Jelly.
three, four,
I'm gonna send you a GIF.
So it's 5. So it'd be 5.
Okay, so what's the calories? So no, it's probably tough.
You get ready. So let me sit back. Good morning. I'm gonna say good morning, Jelly.
Subtract B2 from B4. Okay, so B2.
You like to go out talking like that? You call
From
me.
B4, so you start with B4.
Is that a traction part? What I see though.
Oh, I thought you said subtraction. So you're subtracting from B4.
That's what it got confused last time. I know what you guys did. I do it both ways. So one of them's trying, you guys, when you're trying to subtract 122.35 to 97, and another one's trying to 97. So
I'm gonna say, you make me feel
yeah,
like.
so one's gonna be positive, one's gonna be negative. So it's the same answer. It's a positive.
No, it'll give you.
That's a toxic level. I don't
Well,
know.
isn't it subtract B2?
Well, I think you guys were talking about the last one with the -5.
Yeah.
Oh, no, wait, no, you're right. It is from.
If you're subtracting B4, subtract B4 from B2.
Yeah, because it's saying. So it's,
Yeah. So if you're subtracting something from B4, you're gonna subtract something from B4.
I'm gonna send this one. I'm gonna send you what I'm saying.
It's 25.331. Oh, they're gonna be- Oh, then the rest of it just our own house.
So subtract. Oh, wait.
I'm gonna be like, can you buy me Dutch Brothers today? That ain't
No,
shit.
that was for
That
grams.
was for the grams. Yeah, that was for the grams. What about the calories then?
Tomorrow I'm gonna be in there, I'm gonna say, can you come down to the library? Is every single? Oh, Wednesday, I was saying. Can you take some library for us to study? She gonna be like,
I
I
have
got
this
it.
one on Boston, 5.331.
I'm gonna stay until like 5 o'clock. And I was like, I'm ready, babe. You know, you already picked me up for library. No, no. I picked me up for library. I was at work, yeah.
Oh, right there.
Would it be like right there, like by the 9 or 7? Calculate the calories lost by water.
Yeah, that was your feed set.
Oh.
Cows was like equal to the ice, so it would be divided by grams of ice.
Cause I wasn't thinking of a nerd.
So that's fusion for midnight.
Oh, for the. It seemed like. That's it. That's it. You would do B4 minus B1. B2 and B4.
Ebony, ¿qué acabas de hacer?
These two of them, you put it on seven. If you had the ice, it's
Make sure you guys get the measurement after the ice melt.
Would you pass it around? We have to get the measurement after this one. So we have to pour the water back in here. Wait, Ebony, pour it in here?
Yeah, it'll help figure out something down the line. Or you can just, Sydney said water.
That was minus the soap. I don't understand. Well, we can go back to that. We can just grab this. Well,
I don't know.
yeah, let's take
The
it.
water.
Okay, so once you guys clean
That'd
up,
be
the other things happen nicely, you guys can take a break, and then we'll come back and we'll talk about. Okay, so we got 15 minutes to go over chapter 3 and chapter 5. So this is what we're gonna do. The chances are we're not gonna get to chapter 5. We're gonna finish chapter 3, right? If we don't finish anything that we don't finish, you're still responsible for it. So you want to make sure that we're finished. So I need you guys to pay attention real quick. Okay, so tomorrow we're gonna start here, even though I said we're gonna start with the lab first. We're gonna start here and then we're gonna move to those who are pregnant and stuff. So then we're gonna start here, okay? Because we got to get to chapter 5 and chapter 20. Otherwise, you guys are gonna be taking a test without looking at either of those two chapters, right? Okay, so let's talk about real quick. So how many grams are in 0.71 kilograms? How would I do that conversion? 0.711 kilograms.
That was -3, right? Regular 3.
It's regular food? Okay, 10 to the
power
3rd. Okay, 10 to the 5.
So you're gonna do 10 to the power 3.
How many grams are in a kilogram? Okay, so 10 to the 3rd, right?
Yeah, and then you're
Okay.
gonna divide it by 1.
So we have
Cross it
1
out, right?
kilogram at the bottom and 10 to the 3 at the top. Grams. So kilograms are going to cancel out. Set, and we have 711 grams. Okay, piece of cake?
This for now, yeah.
Yes.
Can we do with that, like, the weight?
No, we don't want to stress our point.
Yes. Okay.
Because like that one confused me.
Okay. So. How about I pull up the homework problem?
How much is that cost? How much is the cost?
35.
Oh, that's cheap.
Uh,
Do we have to pay for
How
it?
much?
Yeah.
Girl,
To activate it.
Oh,
Expired.
Might expire, that's not doing
Thank you.
Yes, you need to activate your active learning.
That's why you can do different, 'cause it's usually-
Yep. And if I run it, I get to figure out not only how many people got it wrong, but who got it wrong, how long it took them to figure it out.
oh, so you can tell they just guess.
Yep.
Oh, damn.
Okay, so. Okay, so here's an example. Okay, calm down. Yeah, we got this much time to do this much stuff. Okay, now I need you to pay attention. Okay, so Tracy's receiving.
You can Google them, but it gives you like different numbers. Yeah, so good.
8 hours a day.
Okay, well, you know, if y'all don't want to talk about things, I can just give you the test right now, right?
Right now?
Right now, we could go right now. It'll be due tonight at 11:59 p.m.
I'm not laughing at that, actually.
And he's serious too.
Okay, so let's pay attention, okay? So this is your benefit, right? Okay, so Tracy's receiving lanthanine, Lanthanex or lanthanine every 8 hours. She weighs 171 kilograms. The dosage range for the drug is 0.030 to 0.060 milligrams per kilograms every day. What is the maximum dosage in milligrams you can deliver every 8 hours?
This one was a hard one for me.
Okay, so what is our given?
The dose.
8 hours, she weighs 71
0.06 milligrams.
Okay, so we have 71 kilograms. I heard that. Okay, now what was the maximum dosage that she could have
0.060
per kilogram? Okay, now she's receiving this every 8 hours, right? What is the maximum dosage in milligrams you could deliver every 8 hours?
So we're gonna do the 0.06.
Okay, so
Oh, that's something that. Then that would be the total day. One divided.
So it says the dosage range for the drug is 0.060 milligrams per kilogram every day, right? Okay.
So that's get that enough cue.
Okay, so first off, we want to start off with hours, right? We have how many hours?
24 hours a day.
Well, the 8 hours, because we want 8 hours. And you said there's 24 hours in a day.
Yes.
Okay, and then we have our maximum dosage. Okay, so we have 0.60 milligrams per kilogram. And that's for every day, right? One day. Okay, so then this would give us the dosage for 8 hours.
That's it?
We're not done yet.
No, unless you have to convert it.
So it's a third less, so it's 0.020. And that's milligram per kilogram. Okay, we know she weighs how much?
171 or
71. Make her go big girl, huh?
Well, earlier you
171.
said 171 and I was gonna correct you, but then that's what's in my head.
So I'm trying to make her go big.
You sure do.
Okay, 71. And then we know that 0.0 milligrams per kilogram. Okay, what did you guys think? What is chapter 6? How many say figs?
Isn't it
Is it
1.42? It's 1.42.
1.42, but it should have how many sig figs?
2.
2 sig figs, so it should be. Okay. So 0.14, right?
My calculator, something wrong with my calculator, it's not 1.42.
0.142.
No, 1.42.
That's a-
71 times 0.020. So 0.142.
14 milligrams.
1.1.42.
1.42.
That's how I was telling you, 1.42. You're like, no, you have to have
No, right, say figs. So then it should be, how many say figs?
2.
2. So then it's 1.4, right? Okay.
Yeah, there's 1.42.
Well, if it's 1.48, we round it to 1.5.
You're gonna get it wrong.
So you guys have to use the maximum dosage?
Yeah, because it's asking for the maximum safe dosage, right?
Yes.
If they said the minimum safe
Which is,
dosage,
0.3.
then you use the other one. Okay, questions?
Guess.
What was that?
I got one of them wrong, was the gasoline.
The gasoline?
It's the very
I
last.
think I used it only twice. And
I'm not sure.
it was maybe like 30.
You said which question? Was it?
Yeah.
Something like.
I think it's just like, because there's so much going on in class. That field tank, that one.
That one, I got it wrong.
I did too.
I used the wrong.
Yep.
So on the calculator.
Hmm?
What it gives me a different. For the tests, how would that work?
It should give you the same answer, right? Let me see how you type it in, because it really depends on how you type it. Okay. Let me take a look. So you're putting in.
So on this, I see.
All right, so you're ready? And then- Okay, that's because you're doing the answer, you're doing the problem twice, right? So. Yeah, because that's, you did the first part.
I don't like, I don't like.
That's- Okay. So we are at 3 minutes. We use every 3 minutes. Every minute of my 3 minutes. Okay, it says the fuel tank holds 22.3 gallons of gasoline. If the density of gasoline is
0.8206.
0.8206 grams per milliliter. What is the mass in kilograms of the gasoline? in the fuel? Okay, so what's going to be my starting? I'm going to start with the 22.3 gallons, right? Okay, so then we have gallons. How do I convert gallons into milliliters?
Put 1
Because
gallon at the
gallons-
bottom.
I'm gonna put 1 gallon at the bottom.
I only have.
So how many gallons are in a liter?
3.7.
That's right, 3.785. Okay, so then we're gonna add another factor because I have milliliters here, right?
Yeah.
Okay, so then I need to change liters into milliliters. How do I change milliliters to milliliters?
The 0.0010.
Okay.
And then 1 liter, no. Wait. On top,
Put it on top. Okay,
milliliters. And then 1 liter on the bottom.
okay. Or I could have just said 1,000 milliliters on top and one. Shouldn't it be 1,000 milliliters on top?
Yeah.
1,000. Okay. And then that gets rid of milliliters. And I need to put my this guy, right? Density. One down here. Okay, so that can give me my grams, but I want kilograms. So I'm going to kilograms.
You're going to have another box.
box.
Kilogram, you're gonna do 1 gram of water, right? Kilogram, 0.
Okay, so this. Okay. So. Or we could say 1,000 grams equals 1 kilogram, right? Or you could have done it like this. 1,000 down here. So that would work the same way, right? Okay. So then thousands are going to cancel out. Thousands cancel out. So literally it's 22.3 times 3.785 times 0.8206. 69.5. Okay. Get that? See it? Happy to see that?
We have different numbers.
It looks easy, but when I'm doing it, I get confused on what to put, like, for the numbers.
Okay, so let me give you guys a couple of hints, right? You always want to start off with a number that doesn't have any units on the bottom, right? So if it has like grams per milliliter, that's not going to be your starting point. Start off with the one that doesn't have that, right? That's usually the best way of starting. Okay, and then just play with it, right? So then you use your conversion sheet, right? So we know that 1 gallon is equal to 3.3785. No, because we know that it says that, right? And then, okay, so then that means gallons has to be on the bottom, liters have to be on top. And then you're just kind of like getting rid of those units. Just try to get rid of the units to get to the units that you want to get to. And you know that this here is just a conversion factor because it has units on top and the bottom. So you're going to use that as a conversion. That's what we did here. This one, because we wanted to get to. Because we wanted to get to the point where we had mass, right? So we use that density to get to mass. Okay, so we didn't get to where we wanted to get to. Tomorrow we have to talk about temperature. We're going to briefly, we've already talked about sig figs, so we're going to kind of skip over that, and then we're going to talk briefly about temperature, and then we're going to talk about okay. Okay, I'll see you guys tomorrow. You guys have a good day. Get all the homework done. Activate your homework. I don't have that power.
So one of my start place and right where you guys went, you go all the way down there and you take a left. And then you, and then you just go straight and straight and straight, just keep going straight.
Like the drag racing and stuff.
Well, that's my road, so I really don't have to take it.
That's straight. I don't think we can
No, I'm gonna just go. Yeah. Well, whenever we looked it up, it was only 1 minute.
See you guys tomorrow.
Oh, you guys go this way. This way's still faster, I think. This way. No, no, this way is faster. That way.
Have a great day. You too.
We don't go to the hills. I find it faster.
Leave it there. I'll-